Hello and welcome to this episode of the Industrial Engineering Notebook. Today's topic is assembly line balancing. Check out the manufacturing systems video for more information on assembly lines. So let's say in your factory you have a widget that needs built and you have all these little tasks that are required to build this widget. And you want to divide these tasks up into an assembly line that will build the widget for you at a certain rate. So the question is, what should that assembly line look like? And to design it, we're going to follow 5 steps. Number 1, we're going to make a precedence diagram. We'll talk about what that is. Number 2, we're going to set our goal production rate. 3, we're going to calculate ranked positional weight, and I'll define that as well. 4, we're going to group our elements together. 5, we're going to think critically. All right, precedence diagram, here we go. Okay, here are the elements. These are the little tasks that need done. All of these elements need done to make the widget on the other end. And some of these elements need done before other elements. They take precedence. So we'll draw some arrows to represent that. So as you can see, it can get pretty messy, but that's okay. We have some steps to help us out. The other thing we need to know about this precedence diagram is how long each of these tasks take. So we'll go ahead and write that in. We'll just assume that it's in minutes. Cool, precedence diagram is done. We'll check that off the list. Next, we need to set a goal production rate. So if you had one person doing all these tasks to make the widget, they could only do one element at a time. So you would need to go A, then B, then C, then maybe D, E, F, G, H. Or you could switch up the order a little bit, but you could only do one element at a time. So total, one person making this widget would take 3 minutes, plus 4 minutes, plus 6 minutes, plus 1 minute, and so on, all adding up to 52 minutes for one widget, almost an hour. But we want this assembly line to speed things up. I'm going to say our goal is to get one widget out every 10 minutes. Great, step 2 done. Now we need to calculate the ranked positional weights. So there's probably a formula for this, but it's just a lot easier to show you. So I'll say ranked positional weight of A. And what you got to do is add up the cycle time for A. These little times are called cycle times, right? Add up the cycle time for A and everything that depends on A. So in this case, we'd have 3 plus 1 plus 4 plus 2 plus 3. So A's ranked positional weight would be 13. Now we want to do the same thing for B, and this is a little more complicated, but it's the same process. So we would need to do 4 plus both D and E depend on B. So 4 plus 1 plus 2, and these guys feed into H and I, so plus 4 plus 2. And these guys feed into J, K, and L, so plus 2 plus 3 plus 4. J feeds into P, so plus 3. K and L feed into N and O, so plus 2 plus 1. N and O feed into P, which we've already accounted for. So the ranked positional weight of B is a whopping 28. C is at 36, and you can check the math there. D's at 10, and you go through the same process for all of these until eventually you do the ranked positional weight of P, and that's going to equal 3. So I'm going to take away the math now and just show the ranked positional weight for each of these. Cool, so those are all of our weights for each of our elements. Check that off. Now it's time to group the elements. And to do that, we're going to rank the elements from greatest weight to least weight. And I'll write that at the bottom here. So we got our high RPW over here and our low RPW over there. So remember that our goal is 10 minutes. One widget every 10 minutes. Okay, so now we're going to make the first station on our assembly line. We're just going to start filling in elements to this station, going down this list here in that direction. We're going to make sure no station exceeds our goal of 10 minutes. And we're going to make sure we're always following the precedence diagram. So first up, we're going to put C, which brings our total to 6 minutes. Can we put in B? Yep, at 4 minutes we can put in B. Station 1 is done and it comes in at 10 minutes. Next, G. Can we put in G? Yep. So our total's at 3 minutes. Can we put in F? Yep, that would bring us up to 5 minutes. C's already been done. Can we put in E? Yes, because B's already been done. And that would add up to 10 minutes. So this station is done. I'll go ahead and check these off. Next is I. That'll definitely fit. A. Oh, wow. Okay, A is all the way back here, so we can put that in. Our running total's at 5 minutes now. M. Yep, G's already been done, so we can add in M. Wait a second. M is 7 minutes, and our running total is at 5 minutes. So that would bring the station to over 12 minutes. But don't start a new station yet. Let's see if we can add on something else. We have I and A checked off. We couldn't do M. Can we do D? Yes, because all that D requires is that A is done, and we're doing A. So we'll throw D in there, which will bump our running total up to 6 minutes. Can we do H? Yes, because all that H requires is D. So 4 added to the running total will give us our 10 minutes at this station. Okay, first thing we got to do is M, because that had a high position or weight, and we couldn't include it in the last one because it would have taken us over 10 minutes. So we'll start here with M. So our running total is at 7 minutes. I'll check off the H because that's already been done. I'll check off the M because now we've done that. Can we throw in K? Yes, 7 plus 3 is 10, so we got another station done. All right, L is 4, so that'll fit. Then we can throw in J at 2 minutes, so that'll bring our total up to 6 minutes. Can we do N? Yep, because K's already been done. That'll bring our running total up to 8 minutes. We do O, yep, running total up to 9 minutes. Can we do P? No, because P is 3 minutes, so that would take us up to 12, and our goal was 10 minutes. So what we got to do, it's usually not this perfect where you have perfectly meeting the goal at all these early stations, but it worked out that way, and this station did not work out that way. So we could fit 9 minutes, but there was no other element that we could add that would bring us up to 10 minutes. So we'll cap that off at 9 minutes, and then the only other thing left is P, which comes in at 3 minutes. Okay, so we have our assembly line with that little algorithm that we just did there. We grouped our elements. Last step is to think critically. So let's look back at what we've made here. First of all, we hit our goal. Remember, it was 52 minutes with just one person doing this all by themselves. But now we've made an assembly line where we can get out a widget every 10 minutes. Not every 9 minutes and not every 3 minutes, because these guys are going to be waiting on this 10-minute production rate. So even though P can do its job in 3 minutes, it can't put out a widget every 3 minutes. And this station can't put out a widget every 9 minutes because it only receives work in progress every 10 minutes. This is why we got to think critically and where things get a little bit more complex than nice easy equations in textbooks. So at your factory, you have to ask the question. The operator at this station and the operator at this station are going to have a significant amount of time just waiting for work to come in. Was it worth maybe changing your goal to something else? Maybe increasing that up to 11 minutes or 12 minutes and seeing what happens when you go through this process. Or maybe you like the beginning of the process and you just want to lump P in with L, J, N, and O. Then you wouldn't be at 10 minutes, you'd be at 12 minutes for a widget. And because this is putting out one widget every 10 minutes, and if this was doing 12 instead of 9, and this went away, and we had P in there, this station's producing faster than this station, so you're going to have a queue of WIP that just kind of accumulates to a certain level, all because this station is producing faster than this station. So technically, this is the answer to the problem. Things will always be more complicated in reality. So you got to make sure you think critically about the solution that you get. If you liked this video, please hit that like button. If you'd like to see more videos like this, you should let me know by sending a sweet market signal to me by subscribing. If you have questions, feel free to put them in the comments. Thank you.